Okay, we are talking about USA spending. Hi, everyone. I am Choi Hutong Fitness. And my topic is 2024 Federal Road Federal Agency Spending Patterns Analysis. And my data set is from usspending.gov. Click to download the data, then choose customer account data. Here is the My Dataset options. The next line, it shows about the My Dataset is in CSV format with about 2,000 rows and 22 columns. Here are the important key fields and the explanation. In the next lines, shows about here are the data processing steps. The first one is feature engineering that creates new column like application rate and ratio. The second one is log transformation that transform large number in log scale. In the next line about the step three is run the theoretical encoding to convert string to number values. The next step is select features for tuning. In the next line about experiment using k-means, clustering with k equals to 3 is done. The result is plotted along the PCA set. In the next line about the after that, we tried to use elbows method to find the optimal k. We think the k is optimal at k equals to 7. And the next line about this is the final k means results with k equals to 7. The next line is about the reported the clustering results back to automation in current and costs outlay amount. In the next lines is about the cluster one, a percent high active account. The majority agency is Department of Healthy and Human Services, and the majority function is healthy. The cluster two represent accounts with minimal spending. The majority agency is Department of Transportation, and the majority function is natural resources. The cluster three is partially active account with balanced spending. The majority agency is Department of Agriculture and the majority function is general government. The cluster four is account with significant spending. The majority agency is Department of the Treasury and the majority function is income security. In this next line, it's about the cluster five represent a account with the no obligation. The majority agency is Department of Education, and the majority function is education, training, employment, and social service. Cluster six represent inactive account. The majority agency is Department of Interior and the majority function is natural res- resources and environment. The cluster seven is overspending account. The majority agency is federal communication commission, and majority function is commerce and housing credit. Okay, I will pass the microphone to explain more.
So I'm Wang Yin, and I will discuss how demographic factors influence departmental spending. Next. So the objective of it is to develop a model based on the demographic and historical data from 2017 to 2024 to predict the changes in departmental spending. By understanding this influence, we can better inform spending decision within the department. And I have utilized two different models for this analysis. The first one is the linear regression model, which helps us to identify department with strong predictive capability. The second one is the random forest regression model, which allowing us to explore which the demographic factors contribute most significantly to spending prediction. And we have also created some visualization, including a heat map to display the correlation between demographic features and departmental spending, as well as a scatter graph to illustrate the changes over time. Next. To select the department for the analysis, I have focused on the top 9 agents by spending amount, using the data from the spend use CSV file. And next, for the demographic data reanalysis, they include the population age 65 or older, the life expectancies across different age group and races, the median age of the population, yearly data on the total population in United States, percentage of population living in urban area, and the birth rate. Next. So here's the result of the linear regression model. We evaluate the performance using matrix such as the R-square to provide an insight into accuracy of our prediction for department spending based on demographic data. Next. So here is the top 3 departments that perform well in the model. They are the Department of Health and Human Service. Second is the Department of Social Security Administration. And the third one is the Department of Veterans Affairs. Next. So for the random forest regression model, we are building it based on the result of the linear regression model and apply it to the data from the top 3 departments. So this analysis aims to identify which of the 6 demographic factors most significantly influence department spending outcome. So across all 3 departments, we find that the urban population age over 65, and the total population consistently emerge as the most important factor in the predicting spending. Next. We also use the heat map to estimate the correlation between this factor and departmental spending. The analysis relevant that the median age, total population, and the urban population have the strongest correlation with spending. Additionally, next, we have the scatter plot to indicate the population age 65 and older, the median age, total population, and urban population have a positive relationship with the spending trends. Next. So in summary, we have evaluated model performance, factor contribution, and factor correlation. And this insight enable us to have a better budget adjustment and resources allocation. We're using the model insight to adjust the budget across department to maximize the spending efficiency. The second is the future spending prediction. We apply the important demographic factors to identify the model to forecast future spending need. And the last one is to identification of the high risk department to identify that the department has the risk of budget shortfall or increasing spending pressure. We can develop proactive strategy to address potential issues. So I'll pass the mic to Tony.
Thank you, Renee. Hello, everyone. This is Chen Dong. I will discuss my analysis of U.S. federal spending data for California using machine learning to unveil patterns and create predictive models based on 2024 federal contract data. For backgrounds on and objectives, my goals are to develop models to predict contract amounts, find natural grouping in the data, and offer insights for better decision by agencies and contractors. I have streamlined a large data set of 286 columns by focusing on 14 key variables like agency names and contract types, concentrating on California-based contracts for a regional analysis. For exploration is sold, the Department of Defense is the largest spender in California. Contracts are with a skewed distribution and are spread across major counties like LA, San Diego, and Orange County. For modeling, I engineered features through one-hot encoding and applied regression models and clustering techniques comparing k-nearest neighbors, support vector regression, and natural networks. KNN surpassed others with an R-squared of 0.69, explaining nearly 70% of variance in contract amounts and supports the ideas that similar contracts have similar value. Clustering revealed 4 main contract groups. Clusters are dominated by the Department of Defense. Amounts then are averaging from 7.1 million to 18.28 billion. Here, KNN identifies 5 similar existing contracts to predict new values fitting well with government contracting's complexity despite certain limitations such as sensitivities and sensitivity to outliers and challenges in high-dimensional spaces. The analysis reveals contracts with similar features tend to have comparable values, spending clusters in just 4 mega contracts accounting for billions. The Department of Defense leads federal spending in California. The model improvements could be feature weighting, distance weighting, and log transformations. Future research should delve into mega contracts and agency spending behavior differences. For conclusion, the analysis confirms KNN as a strong tool for predicting federal contract amounts, spending clusters, concentrated in few contracts. These insights guide policy and market understanding, demonstrating machine learning's role in optimizing government spending. Thank you. That's the end of my part.
Thank you and good afternoon. I'm Felix Chen, and my topic is clustering mandatory budget contracts by analysis, behavioral trends, and agency prioritization. Next. So let's start with talking about the objectives. There are 3 main goals to improve government budget management by using clustering method to identify funding patterns, understanding agency priorities, and analysis spending behavior to improve decision making. And the dataset was collected in CSV format from USA spending.government website and filtered for mandatory contract from 2024. Next. And for methodology, so first I summarize basic information. Then in the pre-processing part, I include standardizing contract timeline, filtering missing values, converting financial data to numeric format, and scaling using the min-max scatter for clustering. And for the model training part, I use the elbow method to find optimal clusters. Then I use k-means with feature of logged financial values and duration to categorize contract. And after I got the result, I use the kernel PCA to visualize it. And the last part is the result and analysis. I analyze cluster by computing and comparing different features in each clusters. Next. And the elbow method is to determine the optimal number of clusters. So k equals to 4 is chosen since it is the best option as the itera drops slowly after this point. Next. And here is the key means result, which use the PCA and plot it in the 2D spaces. We can see that there are 4 distinct groups based on funding and duration, and it shows that there have strong clustering performance with well-defined group. Next. And cluster analysis referral for contract types. First is cluster 0, which is more routine contracts with lowest funding, shortest duration, but highest quantity. Cluster 1 regards as standard contract, which has higher funding, longer duration, but fewer contracts. And it is believed that this contract type may involve standardized government projects. So cluster 2 is strategic contract, which have the balanced funding, duration, and quantity. So this type of contract may involve multiple departments in it. And last cluster is high-valued contracts, which means that there has highest funding, longest duration, but smallest quantity. Next. And for the insight, so for cluster 0, it is believed that as common low-value contracts with general service administration at most. For cluster 1, it is related to international affairs, with the international development and defense. And for cluster 2, it is believed that as mid-range funding deals, and it is led by defense and agriculture. And the last cluster is focused on large infrastructure involved in high-budget transportation contract. Next. So you may wonder, what is the key strategies to ensure funds are allocated to high-impact area? And here are the suggestions. First is to reallocate funds wisely, mean that high-value contracts need better balance in infrastructure investments. Second is to optimize mid-sized contracts to prevent overspending and improve budget efficiency. Last is to enhance transparency for large-scale contracts like monitoring and accountability to reduce risk. And that's all for my part. Thank you very much.
Hi, I'm Li Yueting, and I would like to present future prediction for top 10 obligation products. Next. First, let's discuss the data source. We gather comprehensive data from USA Spending.gov and the World Bank, which provide a solid foundation for the analysis. This data allow us to explore significant trends in federal expenditures over the specific years. For the data processing, we remove dollar signs from the obligation data to facilitate numerical analysis. Moreover, filtering the data set to retain only US data and filter any null values with means. Next. Now let's devote into the linear regression model. The results reveals a concerning downward trend in obligations, with a slope of negative 4.16 trillion. This indicates that federal spending is likely to decrease over time. The intercept, which stands at 8.58 trillion, represents the theoretical starting point of the analysis. Next. To visualize this trend, we plot obligations for the top 10 products from 2017 to 2025, showcasing the updated decline. Next. Conducted a historical data analysis and found intriguing insights through keyword analysis. And the most frequent word will be aircraft support IT. Next. The analysis shows the aviation industry emerged as a critical sector with terms like 1510 appearing frequently. This highlights the importance of aviation in US national defense. Additionally, we observed a shift in IT products, moving from telecom communication service to business application development, reflecting the ongoing digital transformation in the country. Next. For the KMM model, which provide an average accuracy of 54.4%. However, this comes with a high standard deviation, indicating challenges in analyzing product data in isolation. Next. In order to enhance the model's perception, for logistic regression model, we incorporate a new data set featuring key indicators such as GDP growth, military spending, and R&D expenditure. Next. After feature engineering, data achieved an impressively accuracy of 81% and ROC of 0.78. This strong predictive power allows us to forecast future obligations effectively, providing valuable insights into which products are likely to see increased spending. Also, since the overall decline in obligation expenditures, coupled with low GDP and military spending as a percentage of GDP, suggests that future spending increase for obligation products are unlikely. Next. In conclusion, the analysis reveals a downward trend in federal spending. Additionally, the shift in IT products toward business application development significance and important transaction in focus. After implementing feature engineering, the accuracy of our logistic regression model significantly improved, enhancing our ability to make informed predictions. Next. It is the end of our presentation. Thank you for your attention.